Thomas and the CDFM study group. Welcome back. I'm going to be continuing review of CDFM Module 2, Competency 2, Cost and Economic Analysis from the 2020 Study Guide. So I'm going to pick up on page 2220, where it talks about the life cycle composition. So remember we talked about the different ways to estimate costs on an acquisition project. So you can either look at just the types of appropriations used, you can look at the work breakdown structure, or you can break it down in a life cycle cost composition. Remember, you're looking from cradle, from the development of the item, to grave, to the disposal of the item. So you want to look at the types of costs associated with each one of those categories. So it's important to understand the different categories that make up the life cycle cost. And everything you need is on that chart where it says life cycle cost composition. So if you look at, let me just orient you to that chart. So if you look at the entire square, or is it a rectangle? I can't really tell. Maybe if I take my glasses off, I can tell. You see that number 7 is the life cycle cost, and it includes everything inside of that square. Let's say it's a square. Item number 1 is from the cradle, from the development of that item. So the development cost is anything that includes RDT&E. Why is this important to you? If you're given a practical exercise and it gives you all the different types of appropriation, RDT&E, procurement, MILCON, shipbuilding conversion, O&M, operation and maintenance, MILPERS. If it gives you all of those appropriations, then you will have to determine, if they say calculate the development costs for this project, you will need to know that development cost includes everything that uses RDT&E funding. So that's how you look at this when you're studying. Number 2 is your flyaway cost. So we've developed the item. Now it's ready to fly away. We're ready to start the project. So flyaway cost is the procurement dollars that is used to buy the prime equipment, the major end item, for those who are logistics minded, the major end item. So flyaway. So development costs, RDT&E, flyaway, procurement of the prime item, and then weapon system cost is the flyaway cost plus procurement of the support items for that prime item. So prime plus support, which is flyaway plus support, equals your weapon system cost. That's number 3. Then you have a procurement cost. Procurement cost includes everything that's RDT&E. So if you have a list and you have procurement for prime equipment, procurement for support costs, procurement for initial spares, well, all of those costs together make up your procurement costs. So that's number 4. Number 5 is a term called the program acquisition cost, what it costs for me to acquire the item. So including MILCON, military construction, so that's my facilities, the buildings that I need, the MILCON funding that I need to build those buildings. So includes development costs, flyaway costs, let's see if I remember, flyaway costs, which is procurement of the prime equipment, the weapon system cost, which is your flyaway plus procurement of the support item, your procurement cost, which is flyaway, weapon system, and it includes the initial spares, and military construction, which is acquiring your facilities. So all 5 of those items make up the program acquisition cost. So you will see later on there's a formula at the bottom of the page if for them to ask you to calculate the program acquisition cost. or the program acquisition unit cost, which means I don't want to know how much for the entire program. I want to know how much does it cost to develop one unit of the item. So that's what the unit cost you'll see later on. Number 6 is outside of that box because none of that is needed. The rest of it is not needed for program acquisition costs, but it is still part of the life cycle cost, is operations and support. So remember when we went through the milestones and the phases of the acquisition process. So this plays a role in it also. So picture development stage when we started talking about the material solution analysis phase, that's the beginning. And then we ended up with the operations and support. And within operations and support, you use O&M and MILPERS, operations and maintenance, and military personnel. You also have an instance of the grave part, cradle to grave, which is the disposal, and you typically use O&M funding to do the disposal. So the majority of the cost of an acquisition program is in the operations and support phase. So I said it when I did the phases, now I'm going to repeat it. The majority of the costs, the expenses for an acquisition program resides in the operations and support. We have to sustain the items. It might take a year to build it, but the life cycle of the project may be a 5-year project, a 10-year project. Now I'm going to have operations and support funding to sustain it for those 10 years. And then I also need O&M and MILPERS to dispose of the item in whatever fashion, according to the -10 or the SOP for that item. So all of that is out of that chart. If you look at the bottom of page 220, now you see the two calculations that you're going to have to do. The average procurement unit cost. So remember, procurement acquisition cost is all your procurement. Average procurement unit cost is all your procurement, but then they specifically ask you for one unit, and you'll see the exercises on the next page. The other formula is on this last thing on page 20 is program acquisition unit cost. You already know program acquisition cost is RDT&E, procurement, and MILCON. So any one of those values. The examples on page 21, first one is the PAUC, which is the program acquisition unit cost. The second one is the APUC, which is the average procurement unit cost. Now, let me say this disclaimer. Just like when in your real life, when you do financial management, you do not only get the values for the problem that you are working. So do not allow this example to deter you and think you're going to walk into a problem or an exercise and they're only going to give you the volumes, the values that you need for that problem. They're going to give you more. So what am I saying? They're not just going to give you RDT&E, procurement, and MILCON, so you know those are the 3 things I need to calculate the program acquisition unit cost. They're going to throw in some O&M. I mean, if I'm writing the test, I'm going to throw in some MILPERS. I might throw in some shipbuilding conversion Navy just to see, do you really know how to calculate it, or did you just memorize what's on the page? When you study for the CDFM, study for comprehension. Study to ensure that you understand the information. So let's walk through. So the PAUC, program acquisition cost, includes RDT&E, procurement, and MILCON. So they have to give you the units. So these are usable products. So it says I have that unit made up that I spent RDT&E funding in. And then you should know from the life cycle cost composition, if I'm using RDT&E, that one item was developed when? Go back to the next page. It was developed in the development phase. Item number 1 of the life cycle cost, because that's the only one that used RDT&E from this model. Procurement, we had 199. So we bought 199 units. No Milcon facilities were included, so we had 0 there. But so we did spend $1,000, but no units were developed in that item, so we did have some facility costs. So for a total cost of 200 units and $26,000 in RDT&E, Milcon, and procurement. So to do the PAUC, the formula is taking the total dollar, 26,000, divided by the total units, and it'll tell you how much it costs to develop 1 unit. So the program acquisition unit cost is 130,000. The second example is for the procurement cost. So average procurement cost tells you also have to divide, but if they gave me the same values from the top problem, I know that procurement cost only includes procurement dollars. So when I view this, I'm viewing it as if I had RDT&E, I had procurement, I had Milcon, O&M, Milpers. I would know if they asked me to calculate the APUC, I need the units that were developed with procurement dollars. So that's 199 and 20,000. So 20,000 divided by the 199 is 100.5. So that's the average procurement unit cost. So those are the two calculations you have to gonna do with life cycle cost composition. The definitions for those terms is on page 22. Development cost, flyaway weapon system, procurement, operations and support, program acquisition costs, life cycle costs. All right, on page 223, now we look at estimates. Because again, everything that you do in your planning of your acquisition, you have to estimate these costs. So you want to have different methods to do that. And remember, your program manager is your primary subject matter expert in this whole process. So there are 3 types of estimates based on the level in which they are accomplished. The first bullet on page 23 talks about the estimate that is done by the program manager who works for a program office, program PO&E office. They do a program office estimate. So let me rephrase that. The program manager works for a program management office, and they create the program office estimate, the POE. So whenever they put in a project, if it requires an estimate from, and it always will because that's the starting point, your PM does the initial baseline, is the PO&E. That's the term that is used. When it goes up to the components, your component cost person, service component cost analysis agency, they do a component cost analysis. So if it's coming from the Army, since I'm familiar with the Army, who is the cost person at the Army? The DCAPE, Director of Cost Analysis and Program Evaluation, DCAPE. So even though it doesn't say it here, you need to know costs. Actually, that's the DCAPE at the DOD level. But at the service component level, it's the cost personnel. So I'm jumping the gun. I'm looking at my notes, jumping the gun. The DCAPE does the ICE, Independent Cost Estimate, which is the third one. All right, so let me recap. Program manager or the Program Management Office does the POE, Program Office Estimate. The Component Cost Agency, Component Cost Analysis Agency does the Component Cost Estimate. So it's coming up the pipe. And then when it gets to the Department of Defense, that's where the DCAPE comes in. Make sure we know where people work. The Director of Cost Analysis and Program Evaluation, the DCAPE does an independent cost estimate. That's for all those programs. So ACAD 2, 3, and 1C. That's at your component level. Normally, only the first 2 type estimates are done. So if it's one where the milestone decision authority, let's go back on previous knowledge, The milestone decision authorities at the component level, well, it doesn't make any sense to go and do the DK independent cost estimate because you're stopping at the component. So that's what that last line is talking about there. So 3, cost estimate, PO&E, component cost estimate, and the independent cost estimate. All right, page 2 to 24 and 25 looks at work breakdown structure. So you can determine cost estimate based on the work breakdown structure, WBS. And for this, a part of the job is going to cost X amount of dollars. Or contractor, so the government program office use the WBS structure. The contractor work breakdown structure focuses on the control account. So the primary account that's in charge of those particular projects. So it looks at the view from the government work breakdown and the contractor work breakdown structure. So I'm making a note so I can focus on that. All right, so the bottom line on page 26 is it's easier to determine cost, which is the best decision based on cost. So we use cost as an independent variable. But within that cost, you have to consider things like risk, morale, safety. So all of those things that you cannot necessarily quantify them, but how important are they to the project? So once all those things, core objectives have been checked off, when you're doing a course of action analysis, once all the things that's required by that milestone decision authority, by that commander, by that leader has been checked off, then you can base your decision on cost. Even though this project costs less, it may not provide the percentage of safety that we require. So we might have to go with the more expensive project. So that's how you look at it. So cost is used as an independent variable when you're trying to look at cost itself. You're trying to rate your schedule. Are they on track? You know, like somebody come out and fix something at your house and they say, it's going to take 2 days. And you're in day 5 and you're like, okay, this is not what I agreed upon. So is it going to now cost more? Because if you pay them by the hour, now it's taking longer. And I didn't agree on 5 days. I agreed on 2. And I gave you the extra 3rd day, but now you're in the 5th day. So you can place a cost on your schedule. And performance. How well was the work accomplished? And if you've deployed, we've seen some shoddy work where they're like, yeah, that building is done. And you look up at the building, you're like, okay, there are holes, there's seams in the roof. There's plugs hanging out the wall. How do you mean the work is done? So performance, there's a cost because if you can't finish it the right way to standard, now I have to pay someone else and probably gonna have to pay them more because they're gonna have to undo everything that first contractor did to be able to do what we require them to do. All right, so that's cost as an independent variable. The next topic on page 27 is different cost estimating methods. And I guarantee, even though I don't see the test, I don't work for ASMC, so I can't say for sure, but I know that every class, every training that I take, if you say cost estimating methods, these items are always there. I've taken courses via DAU, the Defense Acquisition University. I've taken course via the Joint Knowledge Online, JKO, and anything to do with cost, there's always these terms: analogy, parametric, engineering, actual, and expert. So you need to know what each one means so that if you see a scenario, because none of this test is straightforward, it's always a scenario based to see, are you able to determine which method would I use? Will I use the analogy? Will I use engineering? Am I starting from scratch where I don't have anything in the inventory. So remember, we're trying to build that capability to fill the capability gap that we determined in the beginning using the JCIDS process, Joint Capabilities Integration and Development System. So let's go to the analogy on page 28. So when you read through all of that, the basics behind analogy is I need to develop this vehicle. Analogy approach says I have a similar vehicle already in my inventory. So I can use the cost of developing that vehicle to be the baseline to do an estimate for the new thing that I have to build based on features, characteristics, what it needs to do. And then I can add additional costs independently and then come up with the overall cost. So the definition, the key word with analogy is I have one similar item already in my inventory that I can use to get that cost estimate. Parametric, statistical method, top down. What parametric says is based on the physical attributes. Let's say the vehicle, it's up armored, it has computer, electronic, GPS. So that's a physical, the GPS piece is a physical attribute. The up armor is a physical attribute, which simply means that I can find out what does it cost for that GPS, what does it cost for the up armor piece, and then I take the physical attributes of several existing systems that acts like what I want this vehicle to do. Then I take all those costs, put them together to make up the parametric estimate. So parametric, top down, because I'm looking at things that's our categories of things or physical attributes that are already out there, and then I come up with the estimate. Top down, statistical, parametric approach. The engineering approach is bottom up. I don't really have, and if you read through it, it'll say that I have no existing system that does what I need this capability to do. So engineering means I have to take each piece of the puzzle, come up with the cost for that puzzle, that piece, and then together I come up with the engineering cost estimate. Engineering approach. If you read through engineering, you see it's very detailed, very costly. It's going to cost more time because now I need to calculate the eaches versus taking a attribute, taking a product. I don't have anything in my inventory. So I have to do the engineering, which is also called the bottom up approach. The fourth estimate on page 31 is actual cost. And it's exactly that. Actual cost approach, meaning I want to build more of these types of vehicles. I already have, but I don't have enough. So I have the actual cost of these vehicles already in the inventory. So actual cost means that I can take that to develop my estimate for what I need to build. And then the fifth one is expert opinion. So let's say I don't have enough time to do my research to get the physical attributes, to get the cost of one similar item. So I can take expert opinions, meaning people, different program managers, I take their word for it. And I get their input. Then you use what's called the Delphi technique, is taking input from each one of those subject matter experts, and then I look at patterns. If they all say go with option A, well, using the Delphi technique, I can recommend going with option A. If they all are against an option, then it's most likely that I should go against the item. So this method is not a good thing to use, but sometimes you have those leadership who say, I need an answer right now. Like, okay, this if requires more detail, but you may not have that time to do all that research. So if you have to give your best estimate, then you go to the subject matter experts, get their opinion and how much they think something will cost, because they work with these programs and these physical attributes, computers, systems all the time. They might be able to give you. And you use the Delphi technique to decipher which particular items to use of that opinion. Estimating methods. Page 233 is learning curve, right? So the idea behind learning curve is the more that I do a job, I should be able to take less time to do the job and produce and double my workload, ideally, right? You're supposed to be able to, where it takes the new person 2 hours to do a job, it should take me an hour and less. If I'm doing the same job every day, learning curve says, all right, page 233, continuing with the learning curve. So you're going to have to do a couple of problems, and you have to go actually on page 34. You'll see the examples towards the middle, type 1 and type 2, where you have to calculate the learning curve. So either you will be given the number of hours and the learning curve percentage, and they'll say, well, how many hours will it take to develop the unit number 8? And they'll give you unit 1, and you have to calculate, do the transactions to figure out unit 8. So remember, everything doubles. So let's go to the example on page 234, type 1. So you are given unit number 1, 300 hours with a learning curve of 90%. So a 90% enhancement the longer they do the work. So all you do is you take 300 hours times 90%, it gives you 270. That 270 represents the amount of hours it'll take to develop unit number 2. And if you continue the process, you take that 270 times 90%, and that value, which is 243, will tell you how much to develop unit number 8. So if you're asked how many hours will it take to develop unit 8, you have to take 243 times 90% to develop the hours to develop unit 8. The second type is you're given the hours and the unit, and you have to calculate the learning curve percentage. I will tell you, if you're in the same series, your learning curve percentage is always the same. Now remember, on the CDFM exams, you typically are not allowed to use a calculator. You're not allowed to have your cell phone. So you may have to calculate these out of your head. Remember, long division math? Me, I'm lazy. So what I do, if I'm taking a test like this, and let's say they have 4 choices, multiple choice, 4 choices. They may have 65, 75, 85, 95%. What I do is I'll take, let's say unit 2 is 250. If I do 250 times 65%, my question is, do I get 237.5? Nope. That must not be the learning curve percentage. Or I take 75%, 85%, 90%. So all the choices on the test, I multiply by the number of hours to see if I get the next hour. So, for instance, like they have 237.5 for unit number 4. What I will do is I'll multiply 65%, 75%, 85%, 95% to see if I get the next value for unit 8, which is 225.6. So by doing that process of elimination, I know that 95% is the learning curve, because if I take 95% of 237.5, I will get 225.6. If I take 95% of 225.6, I will get 214.3, and so forth. Or if you're real good with math, you simply have to take 237.5 divided by 250. You take the smaller number divided by the larger number before it, and that will give you your percentage of the learning curve. So those are the two ways in which you will calculate the learning curve. All right, so the next few pages just talks about the different types of contract. You got fixed price contract, that's the price, it's fixed. Cost reimbursable, depending on certain work you do, the contractor is reimbursed for work, so you could just read through those different contracts. What I want to jump to is page 37, earned value management. Make sure you know what the term is, that integrated tool that is used by the government and the contractor representative. On the government, it's usually contracting officer representative, COR, or the KO, contracting officer. So they measured from the baseline what we estimated the cost to be versus what the cost actually is. And we look at the earned value. Did we earn a benefit? Did you do a good job? Is the value of that project more? You know, like when you have a house, you buy it for, let's say, $150,000. If I add on a pool and I add on a sunroom, then depending on how much it costs me to do that, I expect the value of my home to go up. So that's what you're looking at, earned value management. So you have the various formulas on page 38, cost variance, schedule variance. So these are different things that you're going to have to calculate. And how do you see it? On page 39, that chart. So you really have two charts in one. You have project A, B, and C. You have the budgeted cost of work schedule, which is the planned work, or we plan to the planned work and the planned cost. Schedule variance is what you will have to calculate. Cost variance is what you will have to calculate. So just imagine there's nothing in those values. You also have the budgeted cost of work performed, the value of the work that is done. Once the work is done, there's a value. So I'm going to compare the value of the work to what was scheduled. So that's schedule variance. The second chart is I'm going to look at the value of the work, and then I'm going to also compare it to actual costs. Together, those two costs, when you compare them, will give you your cost variance. So for the examples given on page 39, you have planned work of $487. The value of the work once it's done is $487. So budgeted cost of work schedule is what's used to calculate your schedule variance along with the budgeted cost of work performed. So you see all those acronyms on the page 38. All right, so work schedule is $250, but the value of the work done was only $217. I don't want my value to go down and it costing me more to do it. So the plan and the value that I budgeted for was $250. So I say that it's unfavorable schedule variance. Based on the schedule, the value I should have is $250 or more. The value based on the schedule. Project number C, planned work is $719. The value of the work is the budgeted cost of work performed is $847. All right, I want my house to work more. $847 is considered favorable. So what you will have to do is determine, am I on target, favorable, or unfavorable? Second chart is you're looking at the budgeted cost of work performed, BCWP, value of work done, compared to the actual cost of work performed. So cost variance, 487 plus equals 487 on target. That's the easy one. You don't have to think about it. Now project B says the value of the work is $217, but it actually cost me $122. Well, hello, that is favorable, right? I want to pay less and get more bang for my money. The value of the work is $847, but it actually cost me $875. That is unfavorable. So that's the way how to look at it. So you can look at either subtracting is in case they say it's favorable, and how much is it favorable? You take the 217 minus the 122, you take the 875 minus the 847, you say it's unfavorable, and it's unfavorable for X amount of dollars. So depending on what's asked of you. So that's earned value management. The value of what I expect to pay versus what I paid, the value of how much I budgeted based on the schedule that you give me, because remember, cost, schedule, performance, and then I compare that to what the actual value of the work was completed. So when you have projects like this and then you come up with these values, you sometimes have to present charts to the subject matter expert, to the milestone decision authority. So you either may use a PERT chart, document the program evaluation and review technique, where you look at chunks of project and how is it performing. Or you can use the Gantt chart. Gantt chart is typically useful when you're doing planning, trying to see how things overlap. So it's not really specific. If you look at the Gantt chart versus PERT, you see PERT is very detailed. Which task is done in which week and so forth, versus the Gantt chart is just showing an overlapping of events and activities. Economic analysis on page 42. So I'm going to run through this whole part. So that's why I'm kind of taking my time. So economic analysis is when you're trying to do estimates, but you're looking at what the value of the estimate will be in the out years. As a project, if it's a 10-year project, I need to know how much it's going to cost for year 1, 2, 3, all the way through 10. But I need to consider that the value of the dollar today will not be the same 10 years from now. So I need to consider inflation. I need to consider other factors. So that's what economic analysis brings to the table. So you can look through all the different pages to see the steps to economic analysis, the model that is used. But I'm going to page 46, 47 is when you're making your decision based on cost, you're either looking at quantifiable benefits, those things that you can associate a cost to, or non-quantifiable benefits. So cost savings, cost avoidance, productivity improvement. If I enhance my timeliness and I improve more, I'm building more things, I'm developing more things, I can associate a cost with that. So the 3 quantifiable benefits are on page 46. They give you some other examples of how that's broken down on 47. And then there's a list on page 48 of non-quantifiable. Remember earlier I talked about morale, safety, security. I can improve those things, but there's not necessarily a price I can put on that improvement, quantifiable. So review the list of quantifiable versus non-quantifiable benefits. Now, statistics. So this section is a lot of calculations. So you got to take it in chunks and understand it. Most of us should be familiar with the descriptive statistics, mean, median, and mode. And the so what. So what if you say the mean is 10? What does that mean to me? Median. So you're going to have to calculate, possibly, the mean, the median, and the mode. So when you get a list of values, let's say they give you 5 values, they mix them up, the first thing you need to do is to put them in numerical order. So let's say they have 5, 1, 2, 2. You put them 1, 2, 2, 4, 5. The same number of values. If it's 5 values, you need to put all 5 values in order, even if they repeat. The reason you want to do that, because if it asks you for the median, the median is the middle value. Or you take the average of the two in the middle, and that's your middle value. That's your median. Or the mode. The mode is the most repeated value. Like if people are taking tests and you want to know with how many people scored a 90%. That's your mode. How many times that same value is repeated. And then your mean is the average. So if you're giving a test, and what's the average score that everybody is getting? Between 85% and 90%. Okay, is the majority, if the majority is scoring a passing score, then we're good. So that's the value of central tendency. Page 52 looks at dispersion. Where are the values? Are all the values on the left? Are they scattered about? Are they all on the right? So that's when you look at your range and your standard deviation. Range is, you need to know the definitions, is taking the larger value minus the smaller value. So if you had all your 5 values in order, you will know which one is the smallest, which is 1, and which is the largest, which is 5. 5 minus 1 is 4. So my range of numbers is 4. So that's what it's saying. Standard deviation is either 1 standard deviation from the mean, 2 standard, or 3 standard deviation from the mean. Where are all these values falling on this bell curve? And they give you the bell curve on 52. So that's as deep as I'm going to get, or as the study guide gets with these. So don't get all into statistics and trying to, well, how do I calculate 2 standard deviation from the mean? And nah, wrong class. All right, so frequency distribution. Either you're going to use the histogram or frequency polygon, page 53. So most of us are familiar with the bar graph, which is called a histogram. That's the top left. Bars is when you're presenting the data for your decision maker to view. Is it better to view it in a bar graph or a line graph, which is a frequency polygon? Line graph is where you show where everything's plot. Some people are visual, so if they see the line graph with the test scores, it's like, okay, well, the majority of people, it looks like, based on the diagram versus just the bar graph, they may not be able to visualize the line where you could see that, okay, the top score is, and the majority of the people are scoring here versus here. So what you need to look at the data, if it's not a perfect bell curve, then you need to look and see, do you have a skewed distribution? If it's positively skewed, if the top of the bell curve is leaning to the left and it's off to the right, that's positive, meaning the majority of the people is scoring high. It's negatively skewed, and it's if you come, let me see, correlation. It's negatively skewed if it starts off real low, there's only a couple people that's scoring low, and then it gets real high to the other side, and everybody's failing this test. Skewed distribution. Inferential statistics. You may have to do this. So you have a couple of examples at the bottom of page 54. Percentage change. So they give you a value of 1 January, you had 100 engines in your inventory. 1 February, you only had 75. So the question is now, what's the change in your inventory where you take 100 minus 75? Well, okay, 25 items were gone. No, they ask you for a percentage change. So percentage change is taking the 75 minus 100 divided by 100 times 100. So it's negative. It's a decrease is what you want to say. So even though it came out to 25, that's just luck because it's not 25 engines. We're looking at the percent change, which is a negative change. That means I lost 25% of my inventory. So the decreased change in inventory, there was a negative change. And then it continues. On March 1st, it went back up to 100 engines. So what's the percentage change? So it's a 100, the new amount minus the previous amount. So 100 minus 75 divided by 100 times 100. So you're always going to have, wait, did I say that right? No, you're going to take divided by the old value. So the new value minus the old value, 100 minus 75 divided by the old value, which is 75, times 100 will give you 33%. So you know it's an increase because I had 75, now I have 100 engines. So the increased change in inventory, therefore, was a positive change. All right, I like that. All right, so look at correlation. So correlation, let's go to page 56. Positive correlation, negative correlation, or no correlation. What does that mean? All right, so let's start comparing how people score in a test. Let's say if they score high, I'm expecting productivity to be high because they must be smart. So the first one where it says 85% plus positive plus 85%, it's saying it has a positive relationship because as the examination scores go up, productivity is also going up. So that is considered a positive correlation. The middle one is a negative correlation. Why is it negative? Because if you see, you're comparing errors to examination scores. It's saying as the errors go up, examination scores going down. They have an opposite impact on one another. So it's going down. The errors are going down, but it doesn't matter. So it's not like, hey, you can't compare errors to test scores. So high test score equals high errors. So really, is that what I want to know? That if you score high on a test, you're going to make more errors? The lower the test scores, the lower the errors. Probably that's what I want, but doesn't appear that way. So they have a negative correlation. You can't compare errors to examination score. And if the numbers are all over the place, there's no correlation, which is what it's saying here. It's kind of like streamlined. So linear regression, coefficient of variation, they also have those, but I don't think you may or may not have to do anything with those. But make sure you review all the statistics, mean, median, mode, range, standard deviation, inferential, frequency distribution, and correlation, method of correlation. Time value of money. So this will be the last part of it. So the best thing for me to explain this, let's orient you to page 60, 2260. You should be given the present value of the dollar in year one, the discount factor for year two, meaning if I'm doing an estimate, I need to be able to discount the dollar amount for year two, discount the dollar amount for year 3, 4, and 5. It's a 5-year project for this one. So that when I give you a total, the total is based on that discount. All right, so you also see at the bottom of page 60, they give you a chart and it says it's a 4% discount rate is used, and they give you mid-year discount rate versus year end. Typically on a project, you're looking for the whole year. So you're looking for the year end discount rate. But if the problem asks you to use the mid-year discount factor, that's what you use. So read the problems when you get them. So all it is then on page 61, you see the chart. Years, so the project, so this tells me it's a 5-year project. The expected yearly cost is number 2. So let's see, year 1, I expect to spend $10. Year 2, 20, 30, 30, 10. The expected yearly benefits. The first year, I don't expect no benefits, 10, 0, 35, 50, 75. And then you will have to calculate the end of year using the end of year discount factors at 4%. And you'll see those values to the page 60, which is the 0.965 for year 1, year 2, and so forth. So it tells you number 5, number 2 times number 4 will give you your present value cost. So presently today, what I expect to pay in the next 5 years is worth X amount of dollars. So for this example, if I expect to spend $160, the value of that $160 will really only be $88 because the time value of money says the value of my dollar today will be less in the future. And if they say calculate the present value of the benefits, you also see that if I estimate the benefits that I expect of $160 and I discount it based on their 4% discount rate given, then the benefits will only be $135.50 based on today's value. So that's how you work out those problems. And then you look at different projects. You do this for different projects, and then you select the project that will give you a higher benefit, depending on what the rules and the objectives are. Then finally, you have page 62, break even. It's a real simple concept. If I invest X amount of dollars, break even is the point in which I will recover the money that I invested. So the example given is I need to buy a new system. The new system is $1 million and an annual operating cost of $50,000. The proposed system will replace the current system I have, which costs $300,000 to sustain because it's already paid for it, and then now I'm paying every year to sustain it. So it costs $300,000. Therefore, saving $250,000. So it's only going to cost the other one $50,000 versus the $300,000 that I'm paying now. So $300,000 minus the $50,000 is my $250,000. So to break even, to get back that $1 million that I invested, it's saying it's going to take me 4 years to break even, get my money back. All right, so for 2.2, I will recommend that you do the exercises at the back, page 63 all the way through 67, because these are the type of problems associated with the information. For example, the bottom of page 63, you have to calculate the development cost, the flyaway cost. So imagine if all of that is jumbled up. Right now they have it in order, nice for you. On a test, you're not going to be in order. They might throw the program acquisition cost at the top. They might throw life cycle costs at the top. So just remember the definition. Development cost is RDT&E, everything related at the top. RDT&E, flyaway, procurement of the prime item, weapon system cost, prime item plus support, procurement cost, prime item, support, which is your flyaway weapon system and your initial spares. Program acquisition cost is all RDT&E procurement and MILCON of your facilities. Operations and support is O&M and MILPERS. Life cycle cost is everything, the whole total of what's given. So even though in these examples, they give you exactly the numbers necessary, remember on an exam, you might have more information. So you have to know the definition and what each item means. So be sure to review all the exercises, and I'm going to stop here on this because it's a lot of information. Give you an opportunity to go over the information to ensure that you understand and comprehend the different processes. I recommend that you separate the items. If I'm talking about life cycle costs, let me calculate those. If I'm talking about inferential statistics, let me just deal with that and figure that out. And if you take them in chunks, understand them in chunks, what are my cost estimating methods and all of those things that I went over. All right, so this ends CDFM Module 2, Competency 2, Cost and Economic Analysis. Be sure to subscribe, share these videos with someone who's studying for their CDFM, because the good thing with these videos is you can pause them. You can go back to your book and review the information, then you can press play again to make sure you understand. So this is Helen Thomas and the CDFM Study Group. Thank you for stopping by, and I'll see you guys again next time.